Okay, so we all know the rule, right? Nothing can travel faster than light. It's like physics 101. But have you ever really stopped to think about why? I mean, why is there a speed limit in the universe at all? Yeah, we know the number. It's roughly 300,000 kilometers a second. But that's not the real mystery here. The big question isn't why it's that specific speed. It's why is there any limit? What would a universe even look like if there wasn't one? So to really get why this limit is so critical, let's do a little thought experiment together. Let's just pretend it's gone. Poof, no more cosmic speed limit. What happens? Well, the very first thing that completely shatters is our ability to predict, well, anything. See, in physics, we have this idea called the domain of dependence. It sounds complicated, but it's not, really. Think of it like a bubble of predictability. If you know absolutely everything happening inside a little patch of space right now, you can theoretically predict what's going to happen inside a slightly smaller patch of that space a moment later. And this is exactly where our cosmic speed limit becomes the hero of the story. Because things can only travel so fast, at the speed of light. Your little bubble of predictability is, well, it's protected. You can actually predict what's going to happen right here in the next second, because some surprise signal from, say, Mars simply can't get here in time to mess up your results. Cause and effect stay nice and local, nice and orderly. But in our limitless universe, that bubble of predictability doesn't shrink. It just pops. Instantly. Gone. A star exploding in Andromeda could mess with your coffee maker right now. An alien sneezing 1 trillion light years away could change the outcome of a coin flip in your hand. Everything, and I mean everything, could affect everything else all at once. Just think about what that really means. To predict anything, even what's going to happen in this room in the next nanosecond, you'd need to know the state of the entire infinite universe at that exact moment. The laws of physics would be totally useless. So it turns out, the speed limit is what makes the universe make sense. But believe it or not, that's not even the weirdest part. Yeah, a universe without a speed limit wouldn't just be a chaotic mess. It would be completely and utterly dark. Now, I know that sounds bizarre, but it comes straight from the physics that gives us light in the first place. You see, the speed of light, c, isn't just some random number that got picked out of a hat. It's a fundamental constant that pops right out of the basic properties of space itself. You know, how space reacts to electric and magnetic fields. It's literally woven into the fabric of reality. So if c were infinite, the math tells us that one of those fundamental properties of space would have to be 0. And if that happened, you'd completely kill off dynamic magnetic fields. A changing electric field would no longer create a magnetic one. And without that beautiful dance between the two, you can't have electromagnetic waves. No light. You just have a universe of static electricity. No radio, no sunshine, nothing, just darkness. Okay, so maybe, we've been looking at this whole thing completely backward. What if the speed of light isn't some cosmic speed trap telling us how fast we can't go? What if it's actually the fundamental blueprint of space-time itself, the thing that defines the very relationship between space and time? This brings us to something called the space-time interval. It looks like a fancy equation, but it's really just Pythagoras' theorem for reality. It's a way of measuring the true distance between two events, combining space and time. And the amazing thing is, no matter how fast you're moving, everyone agrees on this number. And look what's sitting right there in the middle of it all, c. It's the conversion factor, the glue that turns time into space and weaves them into a single unified fabric. All right, to really get a feel for this geometry, let's try to picture it. Imagine an event, anything. A firecracker goes off. It happens at a single point in space and at a single moment in time. Let's put that right at the center of our mental picture. Okay, now the light from that firecracker, it just explodes outwards in all directions, right? It forms a perfectly expanding sphere of light. Pretty easy to picture that in 3D space. Now for the cool part. Let's add an axis for time, and let's have it point straight up. As our little sphere of light gets bigger and bigger over time, what shape does that trace out in this new four-dimensional space-time? It creates a cone. This is the famous light cone, and it is the absolute non-negotiable blueprint for cause and effect in our universe. It literally carves up all of space-time relative to our firecracker into a distinct past, a future, and, well, everything else. So here's the bottom line. Anything that could have possibly caused our firecracker to go off has to be inside the past part of that cone. And anything our firecracker can ever influence has to be inside the future cone.
And all that other stuff? The vast regions of space-time outside the cone, that's called elsewhere. You can't affect it, it can't affect you. You are causally disconnected. And the speed of light is what sets the angle of that cone. It's the absolute boundary of cause and effect.
But hang on, there's one last mind-bending twist to all of this. A final perspective shift that suggests maybe speed limit is the wrong way to even think about it. Maybe it's just an illusion because we're using the wrong measurement.
Okay, we all think in terms of speed, or velocity. But in Einstein's relativity, speeds don't just add up like you'd think. If you're on a rocket going at 90% the speed of light, and you throw a baseball forward at 90% the speed of light, the baseball does not go at 180% the speed of light. The math gets weird. But there's another way to measure motion called rapidity. And the amazing thing about rapidity is that it is perfectly additive. And the implication here is, well, it's huge. If you think in terms of rapidity, there is no upper limit. You can just keep adding more and more rapidity forever. That speed limit of c only shows up when we try to translate that infinite scale back into our weird non-additive way of measuring things called speed. It's like the universe is doing simple addition, but we're insisting on measuring it with a funky ruler that just stops at the number 100. So, let's put it all together. Far from being some kind of cosmic restriction, the speed of light seems to be the core design principle that gives our universe its entire structure. It's what allows for cause and effect. It's what gives us light itself. And it's what defines the very geometry of space and time. So, in the end, that's the real question, isn't it? We started out asking why there's a barrier, but maybe the real question is, what would reality even be without this fundamental blueprint? It seems a universe with rules, a universe with a speed limit, is the only kind of universe we could ever possibly understand.